Basically, there's a pocket that's 8 by 10, and then there's a 3/8 inch ledge all the way around, and we've got another pocket in there. Then there's a 1/2 inch ledge, and we go actually all the way through the plastic there. So you use these clamps by setting them flat on the piece you're cutting, going across to this little step ladder, and moving it up 1 tooth so that the thing's angled into the piece. That's when you crank it down.
So if you know your cut is going to be 10 inches,
Yeah.
and you want to make sure it's going to be centered in the stock, what you can do is just hold this up to the center of the cutter, and then it's going to be over here after we do the cut. So it's kind of the 10 inches is sort of centered on the stock, and same thing in the Y direction. So 8 inches in Y would leave us about a 1 inch margin on either side within the stock. And then I've also dropped the cutter down so that it's touching the part just barely.
Alright. Now you're going to zero it all by hitting 0. Handy little graph of the pocket that needs to get cut, which is just 10 by 8, subtracting half the cutter diameter. Different corners.
So I'm going to jog the thing off the part just a little bit.
Okay.
And then we can start the spindle up, and the first operation, the first code will be to plunge it into the stock by 1/8 inch.
Okay.
And then we'll do our lateral cuts to do the frame.
So you just type in 3000.
Yep. And then clockwise.
Okay.
And top speed.
Alright. Alright, well, that's close to 3000.
Yeah, okay. So then the first command will plunge this into the material by 1/8 inch. Since 0 is the stock, the stock top, we'll do a negative here, and the feed rate is going to be, let's say, 10 inches per minute. So G1 is a linear move.
Okay.
It's going to be negative 1/8 inch in Z. Feed rate's 10.
Okay.
We can verify that we're in the right coordinates when we jogged off the part.
Yeah,
it's up in the air a little bit. And so it's always good to have like one hand on the switch for your first move to make sure that nothing weird's going to happen. Okay, that's good. So then we're going to do a G1, and we want this thing to drive up. So we're going to be positive in Y, and it's going to be that dimension that we calculated, which is 8 minus half the cutter weight.
7.8125.
Oh, actually, so we already screwed up. That's okay. So we're gonna change the datum to be. I think we can just do it right here. What was the?
Oh yeah, because our X is actually off. So our X is actually supposed to be 0.1875. Okay. We've set our X and our Y, which we screwed up with earlier.
Correct.
Now we're gonna move in the Y.
So what?
7.8125. And positive is.
Yeah. So the table's going to move this way, but that means that the cutter head is
Right.
moving this way.
Ah, okay.
And then
Good to remember.
Do, let's say, 20.
Okay.
Everything's going well. You know, you sort of get a sense of how hard you can push the machine based on how much noise it's making and how much vibration is coming out of the cut.
Not much.
Yeah, not much. So we're well within what we can do there. Okay.
So the next is going to be G1, and that's now we're going to send it to we're going to modify the X, right? And we're going to go to 9.8125. Speed up the feed rate a little bit. Alright, so next operation is going to move the Y, and it's going to go to 0.1875. But in the other direction, oh, I see. It's
These are absolute coordinates.
These are absolute coordinates, yeah.
So be careful, you can set the machine to be incremental, but that's a different. Just kick the trigger.
So the next move is going to be in the X, and it's going to be back to 0.1875.
I like this. I believe the machine's modal, so if you don't specify the pin grade, it's going to use the last one.
Okay.
So
Spindle stop.
take a look at the cut quality here. It's actually quite nice. So there's no swarf sticking to the edge of the cut, which is good, and the chips are nice and consistent. Pretty good thickness.
This is the non-Tormach approved cleaning system. It is, of course, nice when you buy a $9,000 CNC machine to use a $25 Lowe's shop vac. Well, if we're going to do the next one, basically, it's the same numbers, but I have to add 3/8 plus half the... No, I just have to add 3/8, because we've already factored in the cutter diameter, right? And then there's a different Z for all of them. For example, if the cutter here was at 0.1875, 0.1875, if it's in this corner, since we're using the same cutter, I just add 3/8 to the X and the Y. Right? So basically, in here, I can just start adding 3/8, which 3/8 is in decimal.
375.
So 375 plus 0.1875. Okay, I've done my numbers here. Just lots of subtracting 0.375 from the numbers in the first cut. So so the first one, so the machine's there now, okay. Now we can start the spindle up again, I guess, right? And send it to the correct X and Y. You're gonna have... So if you did G2, I assume that's a two-dimensional move.
No, actually G2 is a circle.
Oh, that's nice of them. That'd be...
G2 I think is a clockwise circle and G3 is a counterclockwise.
So then what's a two-dimensional move? Or you just do two one-dimensional moves?
Careful, so your part actually has a flat ledge here, so you actually don't want to go in a diagonal because it would ruin the ledge there. So it's actually two moves. You want to move first in XY and then down. Add as many...
Oh, I see. So G1 you can add as many dimensions as you want. Okay.
And it will linearly interpolate what to do.
Okay. So we would give it the X and the Y now, and then Z has to be a separate command.
Yeah, exactly.
Okay. There it goes. So, G1. And, by the way, mono price, $30. I think the Tormach machine arm is almost $1,000 or something. This is $2-3 brackets, and then mono price. I didn't even put the price. So X 0.5625 and Y 0.5625. That all seems good. It's still got the feed rate at 40, which we saw was okay. And I just hit enter.
Yep. Yep. Seems proper.
Okay. And now I want to move in Z1, sorry, Z, to negative 0.25.
Oh. Yep.
Now my next one will be Z1. The X stays the same, but the Y goes to 7.425. A little scary,
Yeah.
but it seems to be working. So our next bit's 1/2 inch wide, but the cutter is 3/8 wide, so we need to do 2 passes around to actually cut all of that out. Alright, so this cut's going to go all the way through. I've moved to the right inch Y, and it's a 1/2 inch thick piece, but I'm going to go a little further. Yeah, maybe the 0 isn't that perfect either. So here we go. Alright.
chip for this kind of plastic.
Yeah, this is starboard.
Pretty, yeah.
Like I said, the wood's coming out.
Yep. Final cut, which is gonna break off the inner piece of plastic.
You can also use a screwdriver with your hand or something, basically. You hold this down and around if you're being too wild.
Yep. Okay. So for the cut around the outside, you're saying to put a screw through the hole.
Yeah, in fact, basically just like that. They use a screw that's short enough so that you won't go through your spoil board, like a really stubby little screw. And then use the head of the screw to hold the part down right there.
Got it. I was wondering whether you were saying to put a hole through this, which I can't do. Of course, I could place them so that they go in the grooves too, even if I have the screws that are too long.
Actually, yeah.
So that's easy to do.
The zero thickness of wall there.
So, yeah, it comes off really easy. This is even actually not a good blade on this thing.
Interesting problem now. Cutting along the outside, I made sure that I cleared the clamps, but guess what? I had to
Inside the table movement.
so the thing hit a limit switch, and that's it. So what I'm going to have to do, I guess, is pick it up, move it to over here, finish my cutting on this side and around here, and then I'll have to unclamp everything and shift this over such that I can finish off.
I'm eyeballing this cut, and I see that I'm going to have some problems. I'm going to... The cutter's actually going to hit this clamp, but in addition, this is going to interfere. This little spindle. So I'm going to back this clamp off a bit and see if I can move the nut a little further out too, so that I can clear it.
Just because I don't 100% trust myself, I'm going to slow down the feed rate.
That looks close. That wasn't going to make it. Alright, it's a good thing I hit the stop. So, I will reposition that clamp. Reset the interface.
For this last bit, which is a cable strain relief, I'm actually just freehanding it with a jog control.
It's not super critical how I do it, so that's why I figured I should do it this way.